So this is how stars evolve on the HR diagram. So for a star less than 4 mass sun, this is how it evolves. It starts from the main sequence, going to a red giant, then going and moving towards its white dwarf stage. As for a star that is over 8 mass sun, it moves from the main sequence to the super giants, and then it can go into a supernova explosion. Evolution of 4 to 8 mass sun stars is still uncertain. Mass loss in stellar winds may reduce them all to 4 mass sun stars. Red dwarfs are of hydrogen, and helium burning never ignites. Stars in a star cluster all have approximately the same age. More massive stars evolve more quickly than less massive ones, and if you put all stars of a star cluster on an HR diagram, the most massive stars up left will be missing. So as you see here, most of the stars are missing because of the very high activity, and here are most of the stars because of the less activity, because here is less diameters, less mass, and less luminosity, and here and less temperature, but here is very high temperature, diameter, luminosity, and heat, which means very high activity. So the high mass evolve into the giants, the red giants, while the low mass are always on the main sequence. Okay, so there are some stars that have a certain evolution that can appear in its variability, and this can be always explained as in the most simplest ways as the valve mechanism, as the partial helium ionization zone is opaque and absorbs more energy than necessary to balance the weight from higher layers. So this means an expansion, and when it expands, upon expansion, partial helium ionization zones become more transparent. It absorbs less energy. Weight from higher layers push it back inward, which means a contraction, and when this happens, again the process is reversed and we go again to the expansion, and this actually causes variability in as a pulsating star. And actually this variability of the pulsating stars is not fixed. It doesn't have a specific period. It changes according to years. And thank you. This was our today's lecture.